Welcome to a new video. As you may remember, a few months back we took a look at this guy, the AllPowers S300, which is a classic lithium-ion based power station with plenty of power options, good build quality, but also with some limitations outlined in the review video, which is Voltlog 445. Ever since I got it, I've been using it to charge on the go whenever I travel, go on vacation, camping or similar. And to sum it up, I like it because it's small and has just the right amount of capacity and plenty of output ports for my needs. Back in that video, I was contemplating the idea of having it as a lithium iron phosphate based power station because it would mean, at least on paper, that it has a safer battery technology, one that would tolerate some harsher operating conditions and a much higher number of operating cycles when compared to lithium ion. Well, for your viewing pleasure, AllPowers sent me their R600 model, which is lithium iron phosphate based, so I can review and compare it to their lithium ion model. And one of the exciting features I would like to test on this newer model is the UPS function, uninterruptible power supply, but more on that later. Same as before, unit comes really nicely packed, shipped from an EU warehouse, and you also have the option of ordering a foldable 100 watt or 200 watt solar panel to recharge your power station with solar energy on the go. What you see here is their SP033 200 watt solar panel, and we'll have to test this later in the video, but this thing is huge. Inside the package we get this pouch with accessories where we find the solar charge cable, a mains IEC cable, and some user manual documentation. Right off the bat, when picking up this unit, you notice its weight. Even though it advertises a very similar capacity number, 299 watt hours versus 288 watt hours on the S300, this guy weighs 7.3 kilograms, which is almost double that of the S300. And this comes mostly from using the lithium ion phosphate cells, which are not as energy dense as lithium ion, so they have to pack more of them for the same capacity. And for those that are not familiar with the topic, the main advantages of having lithium ion phosphate battery cells over lithium ion can generally be summed up to: number one, cycle life. Lithium iron phosphate being in the 3,000 to 4,000 cycles before losing 20% of their capacity, while lithium ion might experience that as early as 500 to 700 cycles. Number two, you got wider temperature range for lithium iron phosphate, both for operating and for charging. Although looking at the user manual of this power station, I don't see them mentioning this wider operating temperature range. It's likely that they're playing safe. Lithium iron phosphate also have better depth of discharge, so they're not as susceptible to being damaged from over discharging them. And due to their chemistry, lithium iron phosphate is also one of the safest battery technologies, basically not catching fire in many of the scenarios where a lithium ion cell would. But of course, all of this comes with a slightly increased cost and, most importantly, lower energy density. And before I continue with the review, let me mention the sponsor of this video, PCBWay.com, a professional PCB manufacturer with excellent quality and fast turnaround times. But you can get more than PCBs manufactured with PCBWay. They also do PCB assembly, injection molding, 3D printing, machining various parts, so you can have an entire prototype built using their services. Check out their website linked below. For a quick exterior presentation, we have a 15 watts wireless charging pad on the top. We have this big sturdy carry handle. On the front we have two DC jack outputs and one cigarette lighter socket. These are limited together to 12 volts, 10 amps, 120 watts total. Underneath that we have these two AC outputs which can handle 600 watts maximum total with peaks of 1200 watts. In this area we have our USB Type-C outputs, two of them capable of PD, 20 volts, 5 amps each, up to 200 watts total. So I can only hope that both ports can work at the same time, each outputting 100 watts. Below that we have two USB Type-A ports. These are quick charge compatible, up to 36 watts total, 12 volts output. And we'll definitely have to test all of this later in the video. Now, having just two USB Type-Cs and two USB Type-A ports can sure be a deal breaker for some people that need to charge more stuff at the same time. But for my personal use, that's not a problem because 99% of the time I'm not charging more than two devices at the same time. And if you need more ports, there are plenty of options to choose from, as AllPowers has models with even up to 6 USB ports. On the front of the unit there is this display showing all of the relevant information. There's a general on-off button as well as individual sections on-off buttons, plus an LED light which you can turn on from this button. On the right side of the unit, beneath this plastic cover door, we do have an AC input via IAC mains connector, and if you've noticed that we do not get any wall charger included in the box, it's because the unit has that built in. You just plug in a mains IAC cable and it charges from your wall socket directly, and I think that's a pretty nice feature because I always have trouble, you know, finding and carrying with me the charger for my S300. And we also have our solar input connector and a switch for resetting the overload protection manually. There is also the built-in Bluetooth interface, which allows you to connect to this power station with your smartphone by using their app to visualize the stats. I believe it's called the AllPowers app. Overall, the unit looks very slick and I quite like it. It gives you that premium product feeling. The Bluetooth connection seems to be always on as signaled on the display, and as long as the main power is turned on, Bluetooth is always on. Connecting is very straightforward. The app quickly discovers the power station and connects to it. You get battery percentage and remaining time stats, input and output power stats, on-off switch for AC and DC section, on-off for the LED light, and the ability to switch between 50 and 60 Hz, which is all very nice. Similar to their S300 model, the wireless charging pad is once again this big flat section, which causes trouble with newer models of phones that have a big camera bump. This effectively prevents good coupling between the charging coils by introducing this air gap, but nevertheless with this model, I believe that's because it's higher powered, I can actually get my phone to charge with some careful positioning over the charging zone. But for usability, I hope they update their designs in the future to allow for the smartphone camera bumps. For example, if the handle area cutout was a little bigger, I could have easily dropped the camera bump in there. When not in use, the LCD screen will turn off after a timeout, but the Bluetooth connection remains on as long as you have the main switch turned on, so you can monitor it via the app. Charging via AC socket is supposed to happen at up to 400 watts in fast mode, 300 watts in standard mode, and 200 watts in mute mode. And possibly that means the fan is off, which is nice of them to offer so many options just for AC charging to suit your particular usage. And like mentioned, these charging modes are selected and controlled through the smartphone app. And indeed, by switching to fast mode, I was able to get over 400 watts input charging shown on screen. That's pretty nice because at this rate charging happens much faster than through a charging brick, an external charging brick, which would have to be pretty big to deliver the same 400 watts. But please note that this will lead to a cooling fan eventually turning on. It's pretty loud, so you'll have to bear with that if you need the fast charging. The solar charge input accepts between 12 volts and 60 volts, so you can have several panels in series if you'd like to increase the voltage, but the maximum current is 12 amps and the maximum charging power is once again limited at 300 watts. For some reason, the solar charge input is an XT60 connector, unlike the S300 power station, which had an Anderson connector on both the solar panel wiring and the power station itself. So here you'll need to use the included special XT60 to solar cable or some kind of an adapter. So what I have here is the 200 watts solar panel option, and I had a choice of getting attacked by seagulls protecting their nests on the roof of my office building, or just testing it in a more limited area in the backyard. So I opted for the safe option, and even so, I was able to get on average 134 watts of power produced by the solar panel. Given the less than ideal positioning of the solar panel, I'm calling this a success because I'm sure I could get more out of this setup in a different scenario with better positioning and better sun. Now for the AC socket output test, this is obviously a pure sine wave output, as all inverters are these days, so nothing interesting to test about that. But regarding the output power capability, and I couldn't think of anything better but plugging in my hot air station. And remember, we have a 600 watts limit on the AC output, but as long as you slowly crank up the hot air station, such as not to create a sudden spike to trigger the protection, you can operate the hot air station at maximum temperature, maximum airflow settings just fine, because it will stay under 600 watts with the occasional spikes that the power station can handle just fine. The UPS function of this device sounds very exciting, and this is described in the user manual as being a 10 millisecond switch time between the AC input and the AC inverter output of the power station. So you keep the power station plugged into your AC wall socket and it will direct that to its AC outputs until the power grid goes down. Then there should be a 10 milliseconds delay before the inverter takes over. So I've set up this very simple experiment where I'm monitoring both the AC input waveform and the AC output to look for any discrepancies. Now, channel 1 yellow trace is mains monitoring through my high voltage differential probe from Mixig, and this is the AC input going into the power station. Channel 2, the blue trace, is monitoring of the AC output on the power station, basically the output of the inverter. And I also have a load, which is my JBC soldering station. I'm using my battery-powered Mixig oscilloscope and my Mixig differential probe. Unfortunately, I only have one differential probe, although two of them would have been nice for creating the safe conditions for this experiment. Now, the experiment can still take place, just with great caution not to short anything through the oscilloscope probes and the input section of the oscilloscope, because there is a common earth connection between the AC input and the AC output of the power station. Now, this being a battery-powered scope, it means it's isolated. The differential probe adds another layer of isolation, so we should be safe. It shouldn't matter what I connect on the output on channel 2. What we immediately notice is that the two waveforms, input and output, are synced. So the input is now likely routed to the output and they look like perfect sine waves. Now let's see what happens when I disconnect the input. And there you have it, event captured on the oscilloscope. Let me just zoom in on this. And it looks like we have a switchover time of roughly 22 milliseconds as measured by my oscilloscope. That's roughly twice the spec, but still good enough. If I would have to guess, probably 99% of the appliances that you might plug into this will not see this 22 millisecond gap happening. They will just continue to run happily. So thumbs up for that. The UPS capability is there and is working as expected. Now, for testing the USB output ports of this power station, I'm using a couple of USB power delivery triggers to switch to 20 volts output. And then I'm syncing 5 amps through my KP184 electronic load on this port and another 5 amps through another trigger device on the second electronic load. The cables I'm using have the special E-mark chips inside, so because if you don't use the proper cables, it will not allow you to go up to 5 amps. So that's 200 watts total on USB Type-C outputs, which is excellent news. This thing can power two very hungry USB-C devices at the same time without any issues. Specs for USB Type-A outputs said quick charge compatible up to 12 volts up to 1.5 amps per port, 36 watts total max. I again used the same setup with some quick charge decoys to trigger the 12 volts output mode, and it was happily syncing 1.5 amps for each of the ports. Testing the DC outputs is a little more challenging due to the high currents involved, which easily melt low quality DC jacks. So I've decided to try a dual connection using each one of the two DC jacks syncing into two separate loads to see if I can pull the maximum 12 volts 10 amps and split that onto two channels. And it survived that with no issues whatsoever. It was happily supplying that 120 watts. And just in case you were thinking of bringing this power station with you on a plane, it's not permitted. It says so in the user manual. And I think security would not allow you to put this on a plane either way due to its high capacity battery. And now for a teardown of the unit. It took a while to remove a bunch of screws on the sides to take the side panels off, then a bunch of screws on the top to free the top part, then a bunch of screws holding the back and front together, and then I was in. Again, we are greeted with the same excellent industrial design with regards to the enclosure. You can see why it feels so robust. There are all kinds of reinforcements, ribs in here. The main screws had blue Loctite on them. Wiring looks good. There is high temperature insulation in here. There's silicon wires underneath that. connectors on almost everything, and again a modular design, which I'm gonna talk more about in a moment. The top part section contains the 15 watts rated wireless charger PCB, plus a board marked MPPT, which is connected between the solar panel input and the rest of the DC circuitry. And judging by this little connector and its labels, there must be more circuitry on the backside of this PCB, something like a small MCU to handle the MPPT algorithm. And as we can see, it also has its own little cooling fan. This is one of the side panels which contains the mains wiring. It's all heat-shrink silicon insulation, again color coded. Connections are pretty much all labeled nicely. It's just too bad that I can't read Chinese. To go deeper, I had to remove some screws from these stiffening panels. I had to disconnect a bunch of other connectors, and I was finally able to get a look at this front-facing board. It contains a lot of DC to DC converters, a Nuvoton MCU driving the LCD, and probably doing general housekeeping of the unit. Here's our separate Bluetooth module plus a separate PCB for the AC output sockets, which have an earth connection that goes back to the main input IAC connector. It goes through this bullet connector. I'm not entirely sure that's permitted under EU laws, so if anyone knows more about that, please leave some info in the comments below. This is our inverter plus AC charging board, and there's lots of stuff going on here as well. We have a nice plastic shroud to direct the airflow from the cooling fan for optimum cooling. And there are in total 2 STM32F3s in here, and I can only assume one is handling the inverter job while the other one is handling the AC charging job. And if I remember correctly, the F3 series have the option of containing like a better 12-bit ADC and some analog peripherals, so I'm pretty sure that's the reason why they chose these. To use these microcontrollers for this particular board. And these sit on some add-on vertical cards, and they don't look off the shelf to me. I think they maybe designed these in-house. And just look at the attention to detail. They have small ferrite rings on the legs of this Y-class capacitor, likely creating some kind of capacitive path to ground for noise reduction, but nice attention to detail. And below that inverter sits the battery pack. The cells are part number WTT32700. These are 6000 milliamp hours, 3.2 volts, lithium iron phosphate with a date code of February 2023. There are 16 of them in here, and they are being managed by this BMS board sitting on one end. I can see a thermistor running its way in the middle of the pack. There's also this 2-pin wire going back to our main board, so that could be some serial communication between the BMS and the main MCU. Honestly, from what I've seen in here, for the cost of this unit, it's crazy how much you get for your money and how well built this thing is. I have the unit back together, and now it's time for my final thoughts on this power station plus solar panel combo. First, you may ask if I'm going to switch to using this lithium iron phosphate unit on a daily basis instead of the S300 based on lithium ion cells. Well, I don't think I will switch to this new one, and let me tell you why. And I like the S300 a lot because of its form factor and capacity rating. It has just the right amount of battery capacity that I need and comes in a small enough form factor and weight that makes it easy to carry with me. And I know I said having lithium iron phosphate would be nicer, would be an upgrade because of the advantages. I'm just not willing to take that with a bigger form factor and almost double the weight. But this R600 is superior in pretty much any way to the S300, and it would make for a great power station to be used at home or around the home if I wouldn't have to carry it around. The R600 itself seems to do better than the S300 even on its USB outputs, which are capable of handling more output power consistently. And having that UPS functionality, it's also a big plus. Same can be said for the lithium iron phosphate safer technology. And it can be a huge selling point for people using these primarily in their homes and wanting that extra safety. Otherwise, if you're just going to use it for when you go camping or traveling, why carry the extra weight if you don't need the extra functionality? It all depends on your personal choice. The S300 with its lithium ion cells will do the job just fine, and because it's nicely built with lots of protection features, it is still a safe product. The solar power option is nice if you're looking to recharge on the go, for example, while you're camping. but if you're just going to use it at home, then perhaps you don't need the solar option. The R600 meets the output specs, and in my opinion that's plenty of power, even more than I need. Then there is the nice status screen giving you relevant information, and the Bluetooth connection for those camping scenarios where you leave the station powering something and you're maybe 4 or 5 meters away wanting to check its status, or maybe remotely turning on the LED light. And all in all, a very nice product, nicely built with a nice selection of features bundled. And should you decide to order one, check out the link in the description of the video and use the discount code shown on screen for a 20% off. Absolutely great value for money. That was all for today. I hope you enjoyed this review and teardown, and as always, I am interested in hearing your thoughts in the comments below. Thank you for watching, and if you enjoy these videos, you can help support the channel with as little as $1 per month via Patreon, or you can just hit that like button, which is free and helps a lot.